Okay, hello. Guys, let's take a look at exit ticket number 6 here. Okay, I printed it. Let's look for a little help here. Guys, number 1, again, they're talking about the equation of vertical motion, y, which is like the ht. All right, the height as a function of time. All right, remember, it's negative 16 t squared plus the initial velocity times t plus the initial height. All right, negative 16 t squared plus, as the initial velocity, they're telling us it's right here with an initial vertical velocity of 14 feet per second. That's what we want there. 14t plus the initial height is right there, 6 feet. Okay? That's the equation. Just a matter of plugging in those two numbers, okay? As this is number 2, talking about a basketball thrown in the air with an initial height of 8 feet. That's all you need to know. Let's take a look at the graphs. Which one starts at 8 feet? Which one is the y-intercept at 8 feet? Looks like it's that one right there. That's 8 feet right there. All right, this one is 4. That's not right. This one is 0. That's not right. And this one's upside down. That's not right at all. All right, there it is. All right. Initial height of 8 feet. Right there, 8 feet. That's where it starts. It comes back down, okay? All right, it's the vertical motion of an object thrown to the air. There it is. What's the initial height? Again, guys, go right up to there. Same thing. What does it say right there? That's 8 feet. All right, 8 feet. So it starts. Let's look at where it starts. That's the initial height. All right, next one, vertical motion. What's the maximum height? How high did it go? Well, it looks like this is 8, and then it goes up here right to here. I guess that's 9, huh? Yeah, that's 9. It goes up to 9. Again, this is the height, and this is the time right here. All right, just think of it like straight up and down. This is the time. All right, looks like it's 9 feet. All right, same thing, thrown to the air. How long is the object in the air before it hits the ground? All right, well, here time starts at 0, tick, 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 boom, here hits the ground right there. It goes up, comes down, hits the ground right there. What is that number? Well, there's 2. This is 1. 1 second. It took 1 second, up, down, 1 second, all right? All right, guys, this number 6, this is a vertical motion equation right here. How long does it take for this object to reach its maximum height? All right, there's a couple things we can do here on this. We can put it into Desmos. Guys, in fact, I think, did I do that already? I might have put that in Desmos. So once I come to grab it out. Okay, I'm back, guys. Thanks. Again, this is the equation right here. I'll tell you what, you're going to need to know that for the test, too. That's the one that I put on the test. And look, it's right. Guys, I gave you an example of it right there. I handed it out. There's the equation right there. All right? Well, let's use that. All right? This is saying, how long does it take for the object to reach its maximum height? Well, look back at this thing. It goes up and hits, that's the maximum height right there. All right? Means the object reaches its maximum height of 64 feet after 1 second. 1 second after launch. All right, so the answer there is 1 second. It took 1 second to get to the top. All right, number 7. Same equation. What's the maximum height? Well, I think we just saw it. 64. Maximum height of 64 feet. That's what that means. After it started up here at 48, flew up here to 64, then started coming back down. 64 feet. All right. Last one. How long is the object in the air before it hits the ground? All right, go back to the graph. Starts here, goes up, 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 down, 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 down. Right here hits the ground, right here. All right, that's 3, 0. Means the object was in the air for 3 seconds before hitting the ground. All right, guys, this was a handout I gave you. That's the exact example. Guys, know that for the test. Know that one for the test. All right, see the answer? All right, guys. That's it for that one. I'll tell you what I want to do. As long as we're on here, let's take a look at exit ticket day 7. All right, let's stop this for a minute. Okay, y'all, hope this works out. Y'all, I just subtracted 50 minus 29, 29 minus 14, 14 minus 5, 5 minus 2 to find out the difference between these, okay? That's the first difference between the y's. Look at the y's. Make sure the x's go down by 1, and they do, or up by 1, and then subtract, start with the big one. All right, there's no constant pattern here, so do it again. All right, 21 minus 15 is 6. All right, 15 minus 9 is 6. 9 minus 3 is 6. All right, so when the second difference, this is the first difference, this line right here. When the second difference is a constant, it's a quadratic. All right, the second difference is constant. All right, let's do the next one. Again, look at the difference. 7 minus 5. We look at the y's. 7 minus 5 is 2. 5 minus 3 is 2. 3 minus 1 is 2. And 1 minus negative 1 is also 2. All right, guys, when the first difference is constant, it's linear. All right? All right, this is number 3. Again, I took the first difference already. 46 minus 25, that's 21. I did the same here. 25 minus 10 is 15. All right? 10 minus 1 is 9. And 1 minus negative 2 is 3. All right? Which we have to do it again. And we do it again, we see. 21 minus 15 is 6. 15 minus 9 is 6. 9 minus 3 is 6. All right, when the second difference is constant, it's a quadratic, okay? Quadratic. The second difference is constant. All right, look at this one. I already did the first difference. Again, 100 minus 64 is 36. And 64 minus 36 is 28. All right, 36 minus 16 is 20, and I kept going. But again, there's no constant number here, so do it again. 36 minus 28 is 8. 28 minus 20 is 8. 20 minus 12 is 8. When the second difference, again, is constant, it's a quadratic. All right? Guys, this one is different. We can do the differences here, but it's not going to help us. But if you notice that this doubles every time, it doubles. So take the ratios. 16 divided by 8, guys, that equals 2. 8 divided by 4, that's 2. 4 divided by 2, that's 2. Again, I'm not subtracting here, I'm dividing. And 2 divided by 1, that's 2. Guys, when the ratio of consecutive y numbers is constant, it's exponential. All right, that's the exponential one. We're not taking the differences. We're dividing. We're looking at the ratio. All right, number 6. All right, guys, subtract. 8 minus 4.5, that's 3.5. 4.5 minus 2 is 2.5. 2 take away a half is 1.5. And a half take away 0 is a half. All right, that's not constant, but do it again. 3.5 minus 2.5 is 1. 2.5 minus 1.5 is 1. 1.5 subtract half you get 1. All right, the second difference is constant. It's a quadratic. All right, not the first, the second. All right, again, this is the one you noticed. It doubles. If it doubles or triples, those are the two you really got to look for. Then you know it's going to be exponential. All right, again, you can write it out. 8 divided by 4 is 2. 4 divided by 2 is 2. 2 divided by 1 is 2. And 0.5 divided by 1 is 2, guys. There's 2 halves and 1. Right? All right, number 8. Subtract. 22 minus 17 is 5. 17 minus 12 is 5. 12 minus 7 is 5. 7 minus 2 is 5. That's the first difference. It's linear. All right? All right, last one. Guys, 29 minus 22, that's 7. All right, 22 minus 13 is 9. I'm going to put it right here. All right, 13 minus 2 is 11. 2 minus negative 11 is 13. All right, those are 13 apart right there, okay? Okay, subtract again. I know it looks kind of weird. So subtract again. I get negative 2, and negative 2. Again, 7 minus 9, 9 minus 11, 11 minus 13. That's constant. It's a quadratic. Okay? Guys, that's it. Thanks.